Imagine waking up in a pitch-black room. You can't see the walls, you can't feel the floor. Around you is only a viscous, heavy silence. Your own breath is the only sound in the entire world. You take a step forward, trying to feel for an exit, or at least a light switch. You start to run, but you don't know one terrifying fact. With every step you take, the room doesn't get smaller. It grows. The walls are moving away from you faster than you can run. The door that was a meter away is now a kilometer away. And no matter how fast you move, you will never reach it. That is the exact room we are living in right now. That room is our universe. When we look up at the night sky somewhere in the wilderness, far from city lights, it seems to us that space is a frozen, majestic painting. Stars hang in their places like bulbs on a Christmas garland. We see the same constellations the ancient Greeks saw. It feels like the universe is a stage where the action takes place, unshakable, eternal, static. But this is the greatest illusion in human history. Space is not a stage, and the void between the stars is not just an absence of matter, it is an active, aggressive force. Right now, in this very second, the space between your retina and this screen has expanded by an infinitesimally small amount, impossible to notice. But if we look at the scale of galaxies, this force turns into a monster. Scientists call it dark energy, but I prefer another name, the eraser. Imagine the universe as a sheet of paper with galaxies drawn on it. Someone has taken this sheet and started stretching it in all directions at once. The drawings aren't moving on their own, but the distance between them is increasing, and the more emptiness appears between them, the stronger the tension becomes. We are used to fearing asteroids, black holes, or supernova explosions. We are afraid of things that might crash into us. But the true horror of cosmology isn't collision. The true horror is isolation. There are places in the universe where this isolation has already become absolute. Massive regions of emptiness, hundreds of millions of light years across, where there are no stars, no planets, no life. If you were dropped there, you would see only ink-black darkness around you. No Milky Way, no Andromeda. Only you and the endless expanding nothing. And the scariest part is that this process is accelerating. The universe isn't just growing, it is speeding up. We live in a cosmic ocean where islands of matter are drifting apart, never to meet again. Today, I want to tell you a story that chills even astrophysicists to the bone. We will descend into the deepest abysses of space. We will discover why we might have already missed our chance to contact alien civilizations. And we will look at the very end of time to see exactly how the last star will die. You might think this is a video about physics. It's not. This is a video about our place in reality, and about how little time we have left to look at it. Turn up the brightness, we are beginning our descent. But to understand where we are going, we need to understand how we even figured out that the ground was shifting beneath our feet. It didn't start with a discovery. It started with the mistake of a genius. To understand the scale of the catastrophe, we need to go back to 1917. At that time, the picture of the world was cozy and understandable. Astronomers believed that the Milky Way was the entire universe. Beyond its borders, only endless static darkness, no beginning, no end. Eternity. In Berlin, in his study, Albert Einstein was finishing his work on general relativity. His equations described gravity not as a force, but as the curvature of space. It was brilliant. But there was one problem. When Einstein applied his formulas to the entire universe, the math gave him a result he refused to accept. The equations were screaming, the universe is unstable. Gravity should either pull all matter into one giant clump, or something should be flinging it apart. The universe had to be moving. Einstein didn't like this. He didn't like it at all. The idea of a dynamic, changing universe seemed like chaos to him. He wanted order. He wanted eternity. So, he did something that would get a student expelled in their first year. He fudged the answer. He added an extra parameter to the equation, the Greek letter lambda, the cosmological constant. a sort of made-up anti-gravity force that held the universe in place, keeping it from collapsing or flying apart. Now it's beautiful, Einstein thought. The universe became a frozen statue once again. But while Einstein was comforting himself with math, on the other side of the world, in the cold Mount Wilson Observatory in California, a man named Edwin Hubble was looking through a telescope. Hubble was the polar opposite of an armchair scientist. A former boxer, a fan of duels, he spent nights freezing in the unheated telescope tower, capturing spectra of distant nebulae. And what he saw destroyed Einstein's cozy world to its foundation. The light from distant galaxies was red. Here, we need to become physicists for a second. You all know the Doppler effect. Remember the sound of an ambulance rushing past you. As it approaches, the sound is high-pitched. E. As it moves away, the sound drops and becomes bass-heavy. Ooh, the sound wave stretches out. The same thing happens with light. If an object is flying toward us, its light waves compress and turn blue. If it flies away from us, the waves stretch and turn red. This is called redshift. Hubble discovered that almost all the galaxies in the sky were red. They are all flying away from us. But the scariest part wasn't that. He noticed a pattern. The farther a galaxy was, the redder it was. The faster it was running away. This meant only one thing. The explosion, as such, didn't happen in the center. The explosion is happening everywhere. Imagine raisin bread dough sitting in an oven. The dough rises. The raisins move away from each other. If you sit on one raisin, it will look like all the others are running away from you. But in reality, the raisins aren't moving. The dough itself is growing. Space itself is expanding. When Einstein learned of Hubble's discovery, he traveled to California. He looked through the telescope, saw the redshift, and admitted defeat. He called his cosmological constant, that same lambda, his biggest blunder. He crossed it out of the equations, but here is a plot twist worthy of a Hollywood thriller. 80 years later, in the late 90s, scientists realized that Einstein was right, even when he was wrong. Lambda exists. Space isn't just expanding by inertia after the Big Bang. No, there is some force slamming on the gas pedal. Einstein introduced lambda to stop the universe, but the universe uses that energy to tear itself apart. We realized we are living inside an explosion. We see galaxies scattering. But if the space between them is stretching, then there must be places where matter becomes catastrophically scarce. Places where the fabric of reality is stretched to its limit. And we found such a place, a hole in space that shouldn't exist. Let's aim our telescopes toward the constellation Boötes. At first glance, it's an ordinary patch of sky. But when astronomers began mapping the universe in 3D, they stumbled upon something that made them wipe their lenses. There is nothing there. Imagine you are sailing on the ocean. Around you are islands, other ships, whales, life. And suddenly, you sail into a zone where the water becomes perfectly smooth and black. No fish, no birds, no wind. A dead calm that stretches for thousands of kilometers. That is exactly what we found in space. This region was named the Buddha's Void, or the Great Nothing. It is a sphere of perfect darkness almost 330 million light-years in diameter. To help you understand how insane that scale is, let's play with the numbers. Our galaxy, the Milky Way, is huge. But inside the Buddha's Void, you could fit thousands of Milky Ways lined up in a row. According to the laws of matter distribution, in such a massive volume of space, there should be about 10,000 galaxies. 10,000 islands of life, stars, and civilizations. Do you know how many we actually found there? 60. Not 60,000. Just 60. It's not even a vacuum. It is a vacuum inside a vacuum, a statistical error that physically shouldn't exist. If you imagine the universe as a skyscraper filled with people, the Buddha's Void is an entire floor where only one person lives, huddled in the far corner. But the scariest thing about this story isn't the numbers. The scariest thing is what our life would look like if Earth were located inside there. Astrophysicist Greg Aldering said a phrase that haunts me. If the Milky Way had been in the center of the Bode's void, we wouldn't have known there were other galaxies until the 1960s. Think about that. When Galileo pointed his telescope at the sky, he saw myriads of stars and nebulae. When Herschel and Hubble looked into space, they saw neighboring galaxies, Andromeda, the Magellanic Clouds. We always knew we were part of something bigger. But if we lived in the void, the night sky would be black. Absolutely black, save for a few stars from our own galaxy. Astronomers of the 18th, 19th, and early 20th centuries would have looked into telescopes and seen only endless darkness. We wouldn't have the concept of an expanding universe. We would believe that the Milky Way is the entire world. We would be certain that we are alone, unique, and the center of creation. Our philosophy, our religion, our self-awareness would be completely different. We would be living in a dark room, never suspecting there is a city outside the walls. Only with the invention of powerful radio telescopes half a century ago would we have suddenly heard a faint whisper from the abyss and realized how deeply we were mistaken. But the Bode's void is terrifying not just because it's empty. It's terrifying because of how it formed. Such giant holes don't just appear. Galaxies didn't just leave. Something pushed them out. Scientists believe Bode's is the result of smaller voids merging, like soap bubbles in a bath combining into one giant bubble. Here too, emptiness devours space, pushing galaxies to the edges, forming dense walls of matter and leaving cold nothing inside. It looks like a disease of space or a bald spot that is growing. And the engine of this growth is that same force we mentioned at the beginning, a force that makes up 70% of everything that exists, yet we know practically nothing about it. We look into the Bode's void and see the future of the entire universe. Because nothing is winning. And this nothing has a name. We have arrived at the main culprit, the very force that inflates the Bode's void and drags galaxies apart. Scientists gave it a name worthy of comic books, dark energy. But don't let the name fool you. It doesn't explain what it is. In reality, it's just a fancy label for the phrase, "We have no idea what's happening, but it's killing us." It is important not to confuse it with dark matter. These are two completely different beasts. Dark matter is glue. It pulls. It helps galaxies hold together, spin, and not fall apart. It is our invisible ally. Dark energy is a solvent. It pushes. It hates structure. It wants everything to be evenly smeared across infinity. And the creepiest property of dark energy lies in how it works with space. Imagine you have a balloon. You fill it with air. If you start stretching the balloon, the air inside becomes thinner. The density drops. That's logic. That's the law of conservation. If you have a liter of water and you pour it into a pool, there isn't more water. It just disperses. With dark energy, it's the exact opposite. It is the only substance in the universe that does not dilute when expanding. If you take a cubic meter of space, it has a certain amount of dark energy. If you stretch that cube to the size of the Earth, the density of energy remains the same. There is simply more of it. Where does it come from? From nowhere. It is a property of the vacuum itself. The more empty space there is, the more energy there is. And the more energy there is, the stronger it pushes space apart, creating even more empty space. It is a closed loop, a self-sustaining apocalypse machine. In school, we were taught the law of conservation of energy. Nothing comes from nowhere, and nothing disappears into nowhere. Dark energy looks at that law and laughs. It creates itself, for free, on an industrial scale every fraction of a second. And these scales are terrifying. If we take all the energy and matter of the universe as 100%, then stars, planets, gas, you, me, your cat, and everything we've ever seen in telescopes, that is just 5%. Dark matter is another 25%, and the remaining 70% is dark energy. Think about that for a second. We are used to thinking the universe consists of atoms, but that's a lie. The universe consists of dark energy. Atoms are just rare foam that accidentally appeared on the surface of a raging, invisible ocean. We are a statistical anomaly. We are a minority in our own home, and this ocean is storming. In the first few billion years after the Big Bang, gravity tried to fight back. Matter was denser. It pulled everything back together. There was hope the universe would break. But about 5 billion years ago, a tipping point occurred. Matter dispersed enough for gravity's grip to weaken. Dark energy seized the initiative. It slammed on the gas, and since then, it hasn't let up. We live in an era of acceleration. Galaxies aren't just flying away. They are running away in panic, and the speed of this escape grows with every second. This leads us to a frightening mathematical fact. If the speed of a galaxy's retreat depends on distance, then sooner or later a moment will come when that speed exceeds the limit set by nature itself. We are approaching a line from which there is no return, a cosmic event horizon that has already begun cutting us off from reality. While you were listening to the previous part, something irreversible happened. Right now, in this very second, several million stars crossed an invisible line and vanished from our future forever. We will never be able to reach them. We will never be able to send them a signal. Even if we invent the technology of gods for those galaxies, we have ceased to exist. This is called the cosmic event horizon. You've surely heard the main rule of physics. Nothing can move faster than the speed of light. Einstein was adamant. It is the absolute speed limit in the universe, 300,000 kilometers per second. But there is a nuance. This law applies to objects moving through space, to rockets, particles, photons. But the law says nothing about space itself. Space itself has no speed limit. It can expand at any speed, even 1 trillion times faster than light. And this creates a paradoxical trap. Imagine you are running on a treadmill. You are running at maximum speed, the speed of light, but the treadmill itself is space, and this treadmill is moving backward, carrying you away from the finish line. While galaxies are close to us, the expansion of space between us is slow. Light easily overcomes this distance, like a runner outpacing a slow treadmill belt. We see these galaxies. Theoretically, we can reach them, but the farther the galaxy, the more space there is between us. And that means the faster the total speed of expansion. At a certain distance, a critical moment arrives, the point of no return. At this point, space expands faster than light can fly through it. Imagine a photon of light leaving such a galaxy toward us. It flies with all its might. It rushes toward Earth at 300,000 kilometers per second. But the space it flies through stretches in the opposite direction at 301,000 kilometers per second. This photon is like a person trying to run up a down escalator. It runs forward, but it is swept backward. The light from that galaxy will never reach our eyes. It becomes fundamentally unobservable. And here is the number that will make you feel claustrophobic. We see billions of galaxies in the sky. The map of the universe seems huge. But due to the accelerated expansion of dark energy, 97% of all galaxies we see in the telescope right now are already behind the event horizon. 97%, let that sink in. We see them only because the light reaching us today was emitted millions of years ago when those galaxies were closer. We are looking at their ghosts. In reality, there, in the present time, they are already unreachable. Even if we build a ship right now flying at the speed of light and set off toward them, we will never catch them. The space in front of our ship's nose will grow faster than we can traverse it. The universe for us is not an open ocean. It is a small cage that is shrinking. Or rather, the cage stays the same, but everything outside runs away from it. What does this disappearance look like? The galaxy doesn't just switch off like a light bulb. It is a slow, agonizing death of light. When a galaxy approaches the horizon, its light stretches more and more. It turns red, then infrared, then turns into radio waves. Time for the observer slows down. The last image before crossing the horizon sort of freezes and slowly melts, becoming dimmer and dimmer over billions of years until it dissolves into blackness forever. This is the great cosmic amputation. The universe is cutting off piece after piece from us. We lose entire clusters of worlds every day. And this leads to a very disturbing thought. We have been scanning the sky for decades in search of signals from alien civilizations. We listen to radio noise, hoping to hear a hello, and we hear only silence. But what if the reason for this silence isn't that no one is there? What if everyone else is simply moving away too fast? In 1950, physicist Enrico Fermi was having lunch with colleagues and asked a simple question that became legend. If the universe is infinite and full of stars, where is everybody? This question has tormented us for 75 years. We listen to the airwaves, we look for megastructures, we send golden records on Voyagers, and in response, we get only deafening silence. The great silence. Usually we look for the reason in biology or sociology. Maybe life is rare. Maybe civilizations destroy themselves with nuclear weapons as soon as they discover the atom. Or maybe they hide, fearing predators. But what if the answer lies not in aliens, but in what we've been talking about for the last half hour? What if the answer is dark energy? Imagine you are shipwrecked. You are on a raft in the middle of the ocean. You write a help note, put it in a bottle, and throw it into the water. You hope the current will carry it to an inhabited shore. But this ocean isn't just huge, it is expanding. Every second, the water between the bottle and the shore grows. The current that was supposed to carry the message to people actually becomes slower relative to the shore. And at some point, the expansion of the water becomes so fast that the bottle starts moving away from the shore, even if it is floating toward it. Your message will never be delivered, not because there is no one to read it, but because the physics of space works against the mail. This is a terrifying solution to the Fermi paradox. Perhaps the universe is teeming with life. Perhaps right now thousands of civilizations are building their Dyson spheres and colonizing planets. But they are behind that very event horizon or rapidly approaching it. Their radio signals, their laser beacons, their screams of, "We are here," fly through the void. But the void stretches these signals, turning them into endless, unreadable noise until they completely dissolve. We might be surrounded by friends, but we are locked in a soundproof room where the walls are moving apart, and here arises a thought that makes you feel uneasy. Perhaps it wasn't always this way. In the early universe, when galaxies were closer, contact was possible. Maybe billions of years ago, there was a galactic network of communication. But we are late to the party. We were born in the era of decaying connections. We appeared at the moment when space began to close the doors. Perhaps civilizations don't die from wars or epidemics. Perhaps the universe simply drags us into solitary confinement cells before we have time to knock on our neighbor's wall. This turns the search for extraterrestrial intelligence into a tragedy. We aren't looking for friends. We are looking for those who haven't yet flown too far away. And the window of opportunity for this search closes every day. In 100 billion years, any civilizations that arise in our galaxy, if the Milky Way still exists, will face absolute loneliness. Their telescopes will see nothing beyond their cluster. Ancient cosmology books describing other galaxies will be considered religious myths. In the beginning, there were many worlds. They will read and laugh at the naivety of their ancestors. For them, the universe will be small, dark, and empty. We are the last witnesses of the grandeur of space, but the price for this view is the realization that we can change nothing. This is a fate of isolation, a long, quiet life in the dark until the last star goes out. Sounds sad, right? But there is a worse scenario, much worse. There is a probability that dark energy won't just drag galaxies into corners. There is a probability that it will go mad, that it will become so strong it starts tearing apart not just the void between stars, but matter itself. And then loneliness will seem like paradise compared to what physicists call the Big Rip. Up to this point, we've talked about a scenario scientists call heat death. It's a long, boring finale. It is death by old age in one's sleep. The universe will simply get tired, freeze, and drift off. Most physicists believe this is exactly how it will happen, but there is one but. We don't know the exact nature of dark energy. We know it exists, but we don't know how it will behave in the future. In cosmological equations, there is a parameter denoted by the letter W. If it equals -1, then we face cold loneliness. But if it is even slightly less, say -1.1, then dark energy turns into a monster. Physicists call this form phantom energy. In this scenario, the density of dark energy grows so fast that it begins to ignore the laws of scale. First, it pushes away distant galaxies. This is happening now. Then, it becomes stronger than gravity inside galaxies. Then, stronger than the gravity of stars. Then, stronger than electromagnetic bonds. This is the Big Rip scenario, and it is the most brutal execution one could imagine. Let's imagine what it would look like. We have a countdown timer to the end of time, 60 million years before the end. Dark energy becomes so powerful that the Milky Way's gravity can no longer hold stars together. Our galaxy begins to dissolve. Stars don't explode, they just fly away from each other in different directions. The night sky, once full of constellations, empties. Only solitary points remain, quickly vanishing over the horizon. 3 months before the end. The force of expansion penetrates the solar system. Earth is torn from the sun. We no longer need the star's gravitational pull to orbit. Space just carries us into the cold darkness. All planets scatter like billiard balls. The sun turns into a receding dot and fades in the distance. Eternal night falls. 30 minutes before the end, phantom energy descends to the planet's surface. Earth's gravity surrenders. The planet can no longer hold itself together. The Earth's crust cracks and explodes. The planet crumbles into shards, magma, and dust, which immediately fly away from each other. If by some miracle you survived, floating in a spacesuit in the void, you have very little time left. 1 nanosecond before the end. Dark energy becomes stronger than electromagnetism. Chemical bonds no longer work. The molecules of your body, your ship, your suit fall apart. You turn into a cloud of atoms. But that is not yet the finale. In the final instant, in a fraction of a second, so small human language has no name for it, dark energy overcomes the strongest interaction in nature, the nuclear force. Protons and neutrons in the nuclei of atoms are torn into quarks. The very fabric of space-time, that canvas on which reality is painted, is torn to shreds. The universe ceases to exist as a single whole. Each particle finds itself in its own isolated universe. No information, no memory, no past. This is total erasure. It is as if someone didn't just burn the history book of humanity, but destroyed the very letters it was written in. Scientists still argue if this scenario is possible. Data from the Planck telescope says the parameter W is very close to -1. We are balancing on a knife edge, a little to one side, and we freeze, a little to the other, and we are torn apart. But if we trust the majority of data, we have good news. Most likely the Big Rip won't happen. Most likely dark energy will remain stable, and that means what awaits us is not instant death in fire, but an unimaginably long agony in the dark. Welcome to the black hole era. If the Big Rip is execution by electric chair, then heat death is slowly fading away in a nursing home. It is a scenario where the universe doesn't break, it just spends all its resources. Imagine the universe is a wind-up toy mechanism. At the moment of the Big Bang, the spring was wound to the limit. Now, 13.8 billion years later, the spring is still unwinding. Stars burn, planets spin, life bustles. But the winding isn't infinite. In 100 trillion years, the process of star formation will stop. Gas clouds from which new suns are born will be exhausted. The universe will stop lighting fires. The last to die will be the red dwarfs. When the last of them goes out, the universe will plunge into eternal darkness. If civilizations remain somewhere by then, they will have to huddle around dying embers, white dwarfs and neutron stars, to get even a drop of heat. But even these embers will cool. They will become black dwarfs, cold stones floating in the void. Matter will begin to decay. Even protons, the building blocks of atoms, are theoretically unstable. Over time, all matter, everything we are made of, will simply crumble into elementary dust. The black hole era will arrive. In this dark, cold era, the only objects left in the universe will be black holes. They will become the kings of the void, devouring the remnants of matter. But even they aren't eternal. Stephen Hawking showed that black holes evaporate. They slowly lose mass, radiating energy into space. And this process takes time the human brain is incapable of comprehending. To describe how long it will take for the largest black hole to evaporate, we need the number Google. That is a 1 followed by 100 zeros. Year after year, century after century, black holes will give their energy back to the vacuum until they disappear. And here lies a thought that changes the perception of reality. We are used to thinking that the era of stars and life is the normal state of the universe. But that is survivorship bias. The era of stars is a tiny instantaneous flash. We live in the first fractions of a second of the cosmos's existence. The universe will be dead and dark, trillions of times longer than it was alive and bright. We are not the rule, we are the exception. We are the brief moment when the spring unwound fast enough to create heat, but not fast enough for everything to freeze. We exist in a narrow window of opportunity between birth and eternal cold. What happens at the very end? When the last supermassive black hole finishes evaporating, the final flash will occur. The last poof in the darkness. And after that, nothing will remain. Only photons flying through endlessly expanding space, cooling to absolute zero. The temperature of the universe will equalize. Energy will be the same everywhere. This is called entropy, maximum disorder. In such a state, nothing can happen. No events are possible. Time loses meaning, because time is a measure of change, and there are no more changes. Past, present, and future merge into one endless frozen nothing. It is absolute silence, and it is eternal. Sounds like the most depressive ending possible, right? To realize that all our achievements, all art, all love, and all struggle will eventually dissolve into a cold soup of particles, and no one will even remember we were here. But this coin has a flip side. Precisely because the future is so terrible, our present becomes priceless. The fact that we are moving toward oblivion makes this specific moment unique. You and I are in a privileged position. We won the time lottery. And here we are. At the end of our journey through the abyss, we saw the Buddha's void, we felt the cold breath of dark energy, and we stared into the face of heat death. This picture might seem terrifying. It tells us we are insignificant, that we are mold on a rock flying nowhere, that all our efforts are meaningless in the face of eternal entropy. But I want you to look at this from another angle. I want to offer you a perspective that turns this existential horror into the greatest privilege imaginable. Scientists call our time the golden age of cosmology, and that isn't just a pretty phrase, it is a literal fact. We live in a unique, incredibly rare moment in the history of the universe. We appeared exactly when the universe had cooled enough to create life, but hadn't yet expanded enough to erase the traces of its origin. We can still see other galaxies. We can still measure the cosmic microwave background, the echo of the Big Bang. We have clues. We have evidence. Imagine a civilization that arises in 100 billion years. They will be just as smart as us. They will build telescopes better than ours. But when they point them at the sky, they won't see anything except their own galaxy. The rest of the cosmos will have gone behind the event horizon. The cosmic microwave background will have stretched so much it becomes invisible. They will have no way of knowing the universe is expanding. They will build models where their galactic island is everything that exists in static, eternal darkness. They will never know the truth about the Big Bang. The history of the universe will be erased for them forever. We are the only ones who know. We are the keepers of creation's memory. We are the lucky ones who manage to wake up before sunset and see the world in all its glory before eternal night falls. This thought fills our life with a strange but powerful meaning. The universe wasn't created for us. It kills us with radiation, vacuum, and time. It doesn't care about our dreams. But we, tiny creatures of carbon and water, manage to do what no star and no black hole can do. We manage to understand it. We manage to measure its borders. We manage to predict its end. We looked into the abyss, and instead of screaming in horror, we pulled out a notebook and wrote down equations. Let oblivion await us. Let our atoms be scattered across the cold void in trillions of years. That doesn't cancel the fact that here and now, in this brief flash of light, we saw, We knew. So the next time you go outside at night, don't look at your feet. Look up. Stare into the darkness between the stars. Remember the Boötes void. Remember the galaxies running away from us right now. Feel that scale. Let it scare you. And then smile. Because you see what future gods will never see. You see the truth. And while the light is still coming to us, we have a job. To study, to discover, and to remember. Thank you for spending this hour of your life staring into eternity with me. If this video made you feel small but important, share it with those who also love looking at the stars. See you on the other side of the horizon.